In this lesson, let us look at this idea of zero potential method. Now you have a circuit like this. We already know that we can use Ohm's law. So for example, if I had a resistor, let us say this resistance was 3 ohms, and you knew that this potential drop from here to there, the potential drop, let us say, was 6 volts. Then you could always say that this potential drop by this resistance gives me the current. So 6 by 3 is 2 amperes, and so the current here must be 2 amperes. This is just Ohm's law, and we have already done enough questions on this. Now the idea here is that we don't know the potential drop across one resistor, but we know that there is a battery and it's all connected together. So we can try and solve for the current using the fact that this potential drop must be equal to that potential drop. One very easy and simple way of doing this is that whenever you have a circuit and there is no point marked with any potential. For example, if I had a circuit like that where there was this symbol is called earth. Now if this symbol is there, then you cannot choose a point to be 0 because this point is chosen by the problem itself to be 0. Now this question here, obviously there is no point that has been chosen to be 0 or any other potential. This 6 volts, it doesn't mean that this point is 6 volts. It just means that the drop is 6 volts. So this drop is 6 volts. So there is no potential chosen for any point. So we are free to choose one point to be 0 potential. Actually you can choose it to be any value, but let us say we want to choose one point to be 0 potential. So in this circuit, let me choose this point to be the 0 potential point. Similarly, in this circuit, I want to choose some point. Let me choose this point to be the 0 potential point. Now if I choose this as 0 potential, there is clearly a drop of 6 volts. Only one point can be chosen. Now we can't choose all other points. But if I choose this and this drops by 6 volts, clearly this point or this point must be at a potential of 6 volts. Notice that this point being potential 6 volts is different from saying the battery has a potential drop of 6 volts. That is because this is 0 and there is a drop of 6 volts, that must be 6 volts. Now if this point is 0 volts, you know this is a wire and everywhere on a wire the potential is the same. So this point is 0 volts, that point is 0 volts, this point is 0 volts. So this point must also be 0 volts. Similarly, this point must be 0 volts because all of these points are also 0 volts. So if you look at this resistance, this point is 6 volts and this point has a potential of 0 volts, which means there is a potential drop from this point to that point across this resistor, which has a value 6 volts. So there's a 6 volt drop. Therefore, this current here I must be equal to potential drop across the resistance, which is 6 volts, divided by the resistance value, which is 5 ohms. And so that gives us 6 by 5 or 1.2 amperes. So we know that this current is 1.2 amperes. Now we can find this using this idea that one point is 0. So we calculate all the potentials everywhere. Now this point in this problem has been chosen to be 0. Well, if this is 0, there is clearly a drop of 10 volts, which means this point here must be 10 volts. Why? Because 10 minus 0 is 10. So if this is 0 and there is a drop of 10, that must be 10 volts. Now if this is 0, this point must be 0. And why do I say that? Because this is a wire, and so everywhere on this wire the potential is the same, and so this must be 0. And this is a 6 volt battery, so this drop would be 6 volts, which means this point here must be 6 more than this point. This is 0, so that means that must be 6 volts. So that is 10 volts, this is 6 volts. So there is a drop this way from the big side to the small side, right? From the bigger potential to the smaller potential. And this 10 minus 6, so the potential drop from here to there is 4 volts. So this current here that is entering this way from the big side to the small side, the current I, so let me call that also I, is not 10 divided by 5, not 6 divided by 5, but the potential drop, which is 4 volts divided by 5 ohms. And so 4 by 5 is 0.8. So we have 0.8 amperes. So what is the zero potential method? Actually, if you had a problem where there was a resistor and let's say there was a battery here, there was another battery there and a third battery here, you can choose in a closed loop like this, you could choose any point to be zero potential as long as it is already not being chosen. So I could have chosen this point to be 0 or that point to be 0. But you can only choose once. And so if I say this is 0, based on this potential for the battery, potential drop for the battery, you can find this potential. And using this you could find this potential. And using this you could find that potential. Which means you know this potential and you know that potential. So you know the potential drop across the resistance. And using the potential drop and the resistance value, you could find the current. Now, this is something that we will use again and again. The idea is a very simple one. You choose one point to be 0 and then use the batteries to calculate the potential at all other points. And if you find out that you now know the potentials at both ends of a resistor, you can use that to find out what is the current. Because you can find the potential drop like we did here and use that to find the current by dividing it by the resistance. So this method is something that will be very, very quick, and it can help us solve a number of problems where there is a full circuit that is given.